All right. Good afternoon. Happy snow day. So this is the beginning of chapter 5. We're going to try and get through. I'll try and post videos for 5.1 and 5.2 today. I'm also working on Notability on my iPad. And some of you know I'm not great with technology, so be patient with me, please. So section 5.1 is titled Polynomial. Oh, also if you hear dogs barking in the background, go ahead and ignore that. They're just wrestling. So, section 5.1 is polynomial functions. Our EQ is how can I classify polynomials and what is end behavior. The warm-up would have been to find the pattern in the table. A lot of times what people try to do is they say, okay, from -4 to -6 is a decrease of 2. And then from -6 to 4 is +10. And 4 to 50 is +46. And there doesn't really seem to be a pattern there. But you also can't multiply to get from -4 to -6 or -6 to 4. And it seems that this is growing quite a bit. But if you keep this pattern going, this increases by 106. And then that is an increase of, I believe, 190. Okay. Seemingly there's no pattern here, but if we go to the next round and just look from -2 to 10, that is an increase of 12. From 10 to 46 is an increase of 36. From 46 to 106 is an increase of 60. And from 106 to 190 is an increase of 84. Again, still not a pattern. They're still not the same, but you might be able to see that if we do this one more time, from 12 to 36 is an increase of 24. 36 to 60 is an increase of 24, and 60 to 84 is an increase of 24. So it took 3 rounds of doing what are called the differences, and we'll get into that a little bit later. But there is actually a pattern in this table, even though it doesn't seem like it right away. We had to go through a couple different iterations of finding the pattern to actually find a true pattern with the values. We'll get into that a little bit more later. A little bit of vocab just to start. This word is monomial. Okay, so we're going to talk about monomials to begin with and their degrees. A monomial is simply just a bunch of numbers and variables put together, and the variables will have the same powers. So, for instance, the number 11 is a monomial. -6x to the 4th is another monomial, and then something that looks like this, 27x to the 3rd, y to the 5th, z to the 12th, is 4 different things put together, but that is also technically a monomial, and then so is -6 squared yt cubed. So, when we talk about the degree of a monomial, okay, the degree is simply the sum of the variable exponents. Meaning we are going to add up the degree, or we're going to add up all of the powers on the variables. Okay, that's what the degree of a monomial is. So if we look at the number 11, there are no variables, and therefore the variables can't have any powers, so the degree of this thing is 0. Again, because there are no variables, it's just the number of 11. -6x to the 4th has a single variable, and that power is 4, so that is degree 4. Here in our third monomial, we have 3 different variables, so we add up 3 and 5 and 12, which gives us a degree of 20. And then here's where you could get tripped up. The key to this definition is that we're only adding up the variable exponents, and this power of 2 is applying to the number -6, not to the variable. So the degree of this thing is simply y to the 1st and t to the 3rd. So this is degree 4, not degree 6. You do not include that 2 because that is assigned to a number, not to a variable. Also, we could simplify this. We know 6 to the 2nd power is 36. So I could rewrite this negative 36y t cubed, and that's a little bit more obvious that the degree is just 4. So as we go throughout the day today, we're going to talk about what degrees are, and the degree is just simply adding up the variable exponents. So moving on, a monomial, if you've in English class, you probably have broken down words with, I had Latin roots back in the day. The prefix mono means one, and so a monomial means one name or one term in math, but we have names for things that are more than just a monomial. So a polynomial, which is a word that we throw around quite a bit, means multiple names or multiple terms, poly just meaning many. So one term, as already stated, is a monomial. An example of that, you can give yourself, again, this could have as many variables in it as you want, as long as they are all multiplied together. So 2x to the third, y to the fourth, z to the 10th would be a monomial. Two terms, 2 is bi, so this is a binomial. An example of a binomial could simply be x squared minus 16, which is something that you had to factor on your test that you just took. And then 3 terms would be a trinomial. We've worked a lot with trinomials. Most standard form, x squared plus 4x plus 12. That's an example of a trinomial because it is 1 term, 2 terms, and 3 terms. And then finally, a polynomial is the word that we use for anything that has 4 or more terms. So anything that's more than 3, we are just going to call a polynomial. So it could be x to the third plus 2x squared plus 7x plus 4, or something like that. So monomial, binomial, trinomial, and polynomial. So we will be using those 4 words to name expressions as we go. The other thing that we're going to do is determine the degree of a polynomial. This is a little bit different than what we just did. The degree of a polynomial is equal to the largest degree monomial within that expression. And then we also have what's called standard form. Standard form of a polynomial is when you rewrite them in descending degree. So here's what I mean by that. Here's a trinomial. There are 1, 2, and 3 terms. If we look at the first term, 12x to the fourth, that has a degree of 4. The second term, minus 15x, has a degree of 1. And the third term, x to the 7th, has a degree of 7. So the degree of this entire trinomial, this whole thing, we do not add up those numbers. We do not add up 4, 1, and 7. The degree of this entire thing is just equal to the largest number you see. So the whole thing is degree 7. And then we're going to rewrite that in standard form. So we put the largest degree term first, and then we do the next highest degree term, which would be 12x to the fourth power, and then minus 15x. So we rearranged the 3 terms so they were in order from largest degree of 7 and then all the way down to the smallest degree of 1. So if we look at this trinomial, kind of similar, but here now is where we are going to add the powers up. So within one term we have x to the first and y to the fourth. So this thing is degree 5. This monomial is degree 5. This is degree 2. And remember, we do not consider the 2 as part of the degree because that is on 8. I could rewrite this as plus 64 y to the fourth because 8 to the second power is 64. So this monomial is degree 4. If I wanted to rewrite this in standard form, I would put negative 15xy to the fourth first because that was degree 5. Then I would put 64y to the fourth next, that's degree 4. And then finally plus 7x squared. So this is what we would consider standard form, and the entire thing would be degree of 5 because that first term had degree 5 in it. So as we go throughout the day, one of the main goals of today's lesson is to classify a polynomial based on how many terms it has and what the degree is. So for this, I would say it is a degree 7 trinomial because there are 1, 2, 3 terms, and then this would be a degree 5 trinomial because again it has 1, 2, 3 terms in it. So that is what we're talking about when we talk about degree. Go ahead and pause the video now if you want to try these problems on your own, but otherwise we are going to put this together. One thing that does happen is you want to make sure you combine like terms before you start moving things around and writing in standard form. So for instance, if I have 8x squared and minus 3x squared, that would combine to be 5x squared. And then I have, just in a different color, I have 15 and 7, which would combine to be plus 22. So even though I had 4 terms to start, this is actually only a binomial. Notice I also wrote it in standard form with degree 2, that 5x squared went first, and then the degree 0 term of 22 went second. So this thing has degree of, nope, not 0, degree of 2. So our classification for that first one would be a degree 2 binomial or binomial degree 2. Second one here is 5 terms. The highest power I see is to the third, but sure enough we have 2 of those terms, so 2 take away 9 would be negative 7. When combining like terms, you keep that power the same. So we've got plus 15x and plus 10x, so that's 25x, and then I bring down the plus 5. That is 3 terms, so that is a trinomial, and the first term is degree 3, so this entire trinomial is degree 3. Okay. So again, we would add powers within a single term, but for a degree, you just take what is the highest power overall, and that sets the degree of the entire trinomial. Okay, the next thing we're going to talk about is end behavior. As we work with things that are higher exponents, so most of the stuff that we've done has been x squared, and we know that if you have a graph of y equals x squared, that's just simply a parabola. As we get to higher powers, x to the third, x to the fourth, x to the fifth, we get graphs that are kind of fun and look a little bit, do some crazier things, have some more rise and fall. So one of the big things that we're going to talk about is end behavior, one of the characteristics. And I don't want to oversell this or undersell it or whatever, but we are going to keep it pretty simplistic as far as the language is concerned. When we talk about end behavior, what I want you to do is think of, ignore the middle of the graph. Okay, so pretend that that's not there. All you're going to do is look at the outside of the graph. What happens? Well, on the left side, the graph ends up going down forever and ever towards infinity, or towards negative infinity. And on the right side of the graph goes up towards positive infinity. So our end behavior for this graph, we are simply going to call down up. Okay, just what happens on the left side and what happens on the right side. So for the second one, again, mentally blocking out the middle of the graph. I'm not concerned with what happens in here. I see that at both ends of the graph, this thing is going down. So this is going to be down, down as the end behavior. So that is, so when we talk end behavior, we have things like down, up, down, down. There could also be up, up, and up, down. So that is just the vocabulary that we'll use. So what we're going to take a look at is what kind of graphs have the same end behavior, meaning they're down and down or they're up and up. And then what graphs have different end behavior, meaning they go down to up or they go up to down. So